6.2 is about inverse functions and relations. So if you're given a coordinate a comma b that's part of a relation, the inverse has to have b comma a. So on number 1, all we're going to do is reverse all of these coordinates. So we're supposed to find the inverse. Let me start with the braces. So if I invert the first coordinate, that'll become 1 comma 3. You're just making the x and the y trade places. So 4 negative 3 would become negative 3 comma 4. And 2 negative 3 would become negative 3 comma 2. All right, and now we're supposed to graph both the function and its inverse. So I'll do the original function in red, 3 comma 1. 4 negative 3, 2 negative 3. All right, so this is a function because it passes the vertical line test. Now let's graph the inverse. All right, when you're given an equation instead, there's a process to find the inverse equation. So my first step is just to replace f of x with y. So there are about 3 steps. Replace f of x with y. Then x and y just trade places. So this y becomes an x. This x becomes a y. And now you're going to solve for the new y. So I'm trying to get y by itself. X plus 1/5 equals 2/5 y. I want to get rid of the 2/5, so I'm going to multiply both sides by 5 over 2. So this becomes y on the right. So the right side becomes y. I'm going to change that back to f. And the way you write an inverse, you write f with an exponent negative 1. This is f inverse of x equals, and now I distribute on the left side, 5 over 2x plus the 5's cancel, 1/2. All right, now I have to graph both. So I'm going to graph the inverse first. So the inverse has a y-intercept of 1/2 and a slope of 5 over 2. So I don't have room to go up 5. So 5 over 2 is 2.5. So I'm going to go up 2.5 and over 1. And I'm also going to go down 2.5 and left 1. And then I'm going to draw a line through those 3 points. And I'm going to label that this was the inverse, f inverse of x. All right, it's kind of hard to graph the original function because 1/5 is kind of hard to estimate. So what I'm going to do instead is take some coordinates that are on this blue line and inverse them. So I see the point 1 comma 3. So this point up here tells me that 3 comma 1 is on the original function. Another point I see on the inverse is negative 1, negative 2. So that tells me that negative 2 comma negative 1 would be on the inverse. And so now I could draw a line through these two red dots. And this will be our original function. Okay, another kind of informal way to check if you graphed both of them correctly. Think of the line y equals x. The line y equals x, I'm going to draw that in green. The line y equals x should be like a mirror of the two relations. And it looks like it is. So if you were to tilt your paper or your screen so that that green line is going straight up and down, you could see that the red and the blue line look like mirror images of each other across that green line. Okay, so let's follow those steps again. You make f of x, y. We know that the original is going to look like a parabola. Keep that in mind. Okay, so then x and y trade places. And now we're solving for this new y value. So x minus 1 equals y squared. Now I square root both sides. This is going to be y equals, and I put plus or minus on this side, plus or minus radical x minus 1. And now change it back. F inverse of x equals plus or minus radical x minus 1. Okay, graphing the original isn't too bad. So we know the original has a vertex at 0, 1. And because the a value is 1, we go up 1, and then we go up 3. So this is our original. Now we have to graph the inverse. Let me label the original. This is f of x. And so I think the easiest way to graph the inverse is to inverse some coordinates we see. So we see a vertex at 0, 1. So I know the new vertex will be 1, 0. Then I could kind of do the up 1, up 3, up 5 technique, but instead of up 1, it's right 1. And instead of up 3, it's right 3, and up and down 1. And if we were to draw the line y equals x, you can see that those two graphs appear to be mirror images of each other. Okay, we learned a long time ago that if you do the vertical line test, it'll tell you whether a relation is a function. Now, if you do the horizontal line test, it'll tell you if the inverse of a relation is a function. All right, and then on the next example, we are determining if these are inverses of each other. One way to do that is if you find the composition, and you could find either composition. So if you find the composition F compose G, if that equals X, they are inverses of each other. Or if you think it's easier, find G compose F, and if that equals X, they are inverses of each other. All right, so we have our choice. We can do F compose G or G compose F. I will do F compose G. So if I want F compose G, I take G and I plug it into the X in the F function. So this will be 8 times 1/8x plus 12 minus 12 equals, so now we distribute x plus 96 minus 12 we end up with x plus 84. If the 84 wasn't there, they would be inverses of each other. But we didn't get just x by itself, we got x plus 84. So the answer is no. They are not inverses of each other. Okay, let's switch it up. Let's try G compose F. So for G compose F, we take F and plug it in right there. So we have 1 over 10. And I'm going to change these to brackets since I need parentheses again. Okay, 1 over 10 times 5 times 2x minus 3/5 plus 3, close brackets. Okay, this equals distributing the 5, 10x minus 3 plus 3. The negative 3 and the plus 3 cancel out, so we just have 1 over 10 times 10x, which equals x. So because we did the composition and the result was x, they are inverses of each other. And that's all for this lesson.